All right, so the function that we are going to talk about today is a radical function. So for radical functions, there are not that many details that you need to remember. There's no asymptote, there's no special like holes or like values that you must look for. However, depending on the type of radical, the domain and the range might be somewhat special. But anyways, let's start off with a radical expression first. How do we solve for an x when it comes to radical expressions? How do we get rid of square root of something? Well, simple. If you have, for instance, square root of x that equals to 2, what do? To get rid of square root, you will have to square both sides, right? Hence that x equals to 4. I mean, if the thing is, right, if you have square root as rational exponent, you know that rational exponent represents radicals, right? If you think about having that squared, it's basically 1/2 times 2, which is canceling out each other. That's why square root is, taken out by squaring both sides. So anyways, so for each of this expression, we have to square both sides in order to find the value of x. First, when you square each side of question A, you will be getting x plus 5 and 2x squared. Guys, whenever students square like a term with coefficient in it, they do forget to square the coefficient part. Please watch out for that. So 4x squared is what you get. So technically, you will have to solve this as a quadratic expression, isn't it? So you will have to move everything to one side. Remember, guys, any expression that has x squared in it has to be solved as a quadratic function equation. Hence, you need to let one side is equal to 0 and push everything to the other side. Can we factorize this? Shall we try? And then, 1 and 5. Perfect. The other way, 5 and 1, negative 5x and positive 4x. That will be 4x minus 5 and x plus 1. So technically, your x then will be equal to 5 over 4, or x will equal negative 1. So that's how you solve it. Isn't that simple? Well, it is simple. However, things might get a little bit more complicated. For our second expression, when you square both sides, the plus 2, right, will make things a little bit more complicated if you keep it as it is. However, if you move the 2 to the other side, then things will be, much more tidy. Now, after putting everything but square root to the other side, if you square both sides, then you will be getting 19 minus 2x and x squared minus 4x plus 4. Again, x squared is involved, so we have to solve it as a quadratic equation, because it is. And then you will be seeing, and then that is minus 15. So 3, 5 with negative here, x and x. So x plus 3 and x minus 5 is what you get. So the x is negative 3 or positive 5. Okay, now, I want you to take a moment here and then think carefully. Guys, we have come up with 2 values of x for each expression, didn't we? But how did we get the 2 values? By solving this quadratic expression, didn't we? The thing is, what we did in order to get the x was not the initial format of the expression. It was the quadratic expression. Sometimes the value that you get is actually not the correct value of the x. We need to confirm whether the values are correct or not by plugging it back into the initial expression. Sometimes it's not the right value. You see? Let's start off with negative 1. So when you plug in negative 1 into problem A, what do you get? You get square root of negative 1 plus 5, 4 equals to negative 2. And we know that this isn't possible. How can we ever get negative 2 by square rooting of 4, right? In fact, we will never get anything negative from a square root of a number, right? Because having, negative on the inside even is not allowed. So negative 1 is actually not the solution for our expression. What about 5 over 4? 5 over 4 will give you 5 over 4 plus 5 equals to 2 times 5 over 4. And if you, excuse me, okay, so that will be 25 over 4, right? Because 5 equals to 20 over 4, and that will be equal to 5 over 2, isn't it? Oh, look at that. This is 10 over 4, which is 5 over 2. It's a match. Hence, this is the only solution for this expression, 5 over 4. What about this? Negative 3 and positive 5. Shall we try? Negative 3 and positive 5 will each gives you negative 3 first, square root. Oh, I don't think it's going to work because this as a negative 3, especially when this is added by 2, is impossible. Well, can you see that? Well, if you don't, then you have to plug it in. So square root of 19 plus 6 now, double negative, right? Plus 2, what is that? 5 plus 2, which is 7, right? That certainly isn't negative 3, so that's out. 7 isn't equal to negative 3, hence it's out. What about 5? When you plug in 5 there, you get square root of 19 minus 10 plus 2, which equals to 3 plus 2, which equals to 5, which does match. Hence, 5 is the only solution here. So do you understand? The values of x, though we got it from the quadratic expression, that is not what we are trying to solve for. We are solving for the radical expressions given over there. So plug the solutions back in to see whether the given solution is indeed the solution or not. So 5 and 5/4. Remember those values. There's only one solution, and many times kids write the value that is not supposed to be written, right? And get the question wrong. Don't do that. All right, now, if you have radicals on both sides like this, again, all you have to do is square both sides. So you will be getting 2x minus 1 when you square this part. And when you square the second part, you will be getting 9 times 1 minus 2x. Right? Again, coefficient is also squared. So technically that equals to 2x minus 1, 9 minus 18x, which equals to 20x, that equals to 10. So x equals to 1/2. And okay, I know it's kind of irritating, but you do have to plug it back in. So when you plug in 1/2 as x, so that equals to 0. What about, that equals to 0 too. You see how 0 equals to 0? So this checked. This is the solution. Okay? Now, last question. Okay, so guys, do you remember I said I don't want to keep positive plus 2 right here because things are a little bit more complicated if I keep it? But here, even if I move my 1 to the other side, well, it's still the same as keeping it here. There's no way to make make the things a bit better. So we have no choice but to square it as it is. Okay, so let's see what happens. When you square this, you simply get 5x minus 6. But when you square this, for those who are confused about this square root of 2x plus 5, right, as a single term, you may use substitution of an a and expand it and plug it back in, But if you're comfortable as it is, this is being squared, right? So that is being squared, hence you'll be getting, first of all, 2x plus 5. And then we need this times that times 2, hence negative 2 square root of 2x plus 5 is given. Then finally, that squared plus 1 is given, right? Okay, so let's try to make things a little bit more clear. Okay, remember what I said before? If you have radical on one side only, keep that radical and push everything else to the other side, right? So technically, if you just get rid of this and this and this, right, and just keep this, you'll be getting 3x, right? Subtract, excuse me, and 6 is subtracted, hence minus 12. And that equals to negative 2x plus 5. And then what you can do is you may now square it again. So for this equation, we are squaring it twice. Here we go. So what do we get when you square it? Okay, so second time squaring. Sometimes you have to square it like 3 times, guys. That is 9x squared minus 72, right? Plus 144. And then that equals to 2x plus 5. Right? So you have to square both sides, and then you are solving it. So technically, if you solve this, you will be getting your values of x. It's quadratic, so that's 9x squared minus 72x, and then there is a 8x subtracted to it, so that's negative 80x, and then that's plus 144, but there is a 20 subtracted to it, so plus 124. Let's see, what can we use? So it's 9 and 124. So technically, we can use, 9 and 1. And then 6, 12, 2, okay, let's see, 6 and then 4 and then 4, 31. Well, you may try different factors and then, see what you can use the factors as. And then you will come up and 62, 2 and, 6. Here we go, 62 and 2. Okay, so the factors of 124, there is a factor of 62 and 2. And if you cross multiply, you will be getting 18x, and this is 62x. So that if you keep them both as negative, ooh, nice. You know how it equals to 80x? Got the factors. Okay, so the whole thing will equal, first of all, 9x minus 62 and x minus 2, so that the values are 2 and 62 over 9. For now, I mean, because don't we have to plug it back in order to see whether the values are correct or not? So let's try from 2. So when you plug in 2, you get square root of 10 minus 6, right? Which is equal to square root of 4, hence 2. And the other side is 2x plus 5, which is 9 minus 1, which is equal to 2. Oh, perfect. They're both equal to 2. So this is okay, right? And 62 over 9, which is equal to, 5 times 62 over 9 minus 6. What is that equal to? And then square root of 2 times 62 over 9 plus 5 minus 1. Well, just check it quickly. And then, if the values do match, then it is the right solution. If not, then it is not. And, I don't think it is. Anyways, so let's, I'll try. Okay, so 310 over 9 minus 55 over 9. And then we have to square root that even. So 54, so 256 over 9. And then what is that? That is 124 over 9. Oops, 2 times. So this was it 2 times? Yeah, 2x plus 5. So it was supposed to be, where is the initial? Oh, plus 5 is outside. Sorry. Okay, so here we go. Plus 9 over 45, right? So square root of that minus 1. So that equals the square root of 169 over, okay, so guys, this is 13 over 9, right? 13 over 9 minus 1 will be even smaller than, this. So, they are not matching. This and this are not the same. This is obviously small. I don't even have to continue. So this is out. So the only solution for the final example is equal to 2. So again, guys, this is a simple algebra if you think about it, but you must double check the answer. That is the only thing that you have to worry about. And when it comes to radical expressions, I think solving them is more important than the function itself actually, because the functions, guys, are quite simple. I mean, honestly, there's not much they can twist, when it comes to functions with radicals. Okay, let's talk about functions then now, shall we? Like I said, the functions are rather simple. Now, consider this. F of x with square root of x and f of x with cube root of x. Okay? The thing is, if the square root of the x is the given equation, then your function graph goes like this. If it's a cube root of x, then the function graph goes like this and that. That is the only thing that you need to memorize, guys. The thing is, if you have an even n, well, as in if the radical is an even radical, like square root or fourth root, right? Then it starts from 0 and it continues on to the positive side, because remember, square root of -1 is not real, right? It's not real, it's imaginary. So technically, we are not allowed to use anything negative. Hence, the domain is positive, and hence the range is positive as well. But for odd degree, remember what cube root of -1 is? It's just simply -1. Well, -a to the 1/3 cube root, right, is equal to -2. For cube root or for any odd root, right, it is okay to use negative numbers, right, as the domain, and the range hence is -2. So you may have both positive and negative side. So that is the only thing that you must remember. And you must memorize these two graphs, because for the remaining equations, if you know this, you can use transformation to graph them. Okay? So anyways, domain and range, looking for them is usually the most popular questions that you will see with radical functions. Okay, here we go. Let's talk about f of x first. Let's look for the domain. Again, like I said, right, this has to be greater than or equal to 0, because we can't have anything negative in it. So technically, this, okay, whatever you have within the square root has to be positive or equal to 0. So you may just get the domain by solving for the inequalities. 2x is greater than -4 then, so x is greater than or equal to -2. That is your domain. In order to make sure that you don't plug in anything negative inside of the square root, this is, right, what you will have to do. Just plug in values that is equal to or greater than -2. Okay? What about the range? For the range, I'd like to use transformation. Now, range is the y value, right? So you must concentrate on the vertical transformation only. So remember, inside the bracket, in this case, inside the square root does not, make a vertical transformation. It's what happens on the outside. There's a negative sign and there's a +3. Remember to reflect first. Your function is reflected, right? Then pushed upward. What kind of range do you see? Think about it. It's reflected first, right? It's reflected, so it will be going like this way, right? Then, well, it's technically somewhere here. Then it will be going up, right, by 3 units. So when it comes to the range, as you can see, it's going down, but it's going down from +3. You see that? So you don't have to graph everything perfectly. If you just apply the vertical transformation, looking at the 3 and the negative, you can get the range really simply without having to do any calculation. So the range, so flip and push up, right? That will tell us that your y starts from 3, then it goes below. Okay, so range is less than or equal to 3, domain is greater than or equal to -2. That's how you get it. Okay, now for our second example, we'll take like 2 seconds. Okay, check the degree, guys. It's odd, right? What did we say about odd radical? Radicals that has like odd number has all real values. It can be positive or negative. It can be anything. Technically, moving them or flipping them or stretching them won't change the domain or the range. The domain and the range are both all real values. Okay? It can be negative infinity to positive infinity for both. Okay? Doesn't matter. So just check the check out what kind of radical that your function has, and then look for the domain or the range, because sometimes you don't have to look for anything anyways. It's all real values. All right, so you see how simple this can be if you just remember some details. And for the domain, for the even radicals, okay, let the within the radical sign as greater than or equal to 0. Then solve the inequalities. That's all you need to do. Okay, and for range, transformation is handy. Or you may just graph this in your graphic calculator and it will tell you. For domain and the range problems, just graph it in your graphic calculator. It's the easiest way. Okay, now, inverse function then. Okay, now let's look for the inverse function and then find out the domain and the range of the inverse function. Okay, now, in order to look for the domain and the range of the inverse function, you can actually use the domain and the range of the initial function. Remember the rule? The domain and the range swaps around for the inverse. So, excuse me. So by using the same rule as before, okay, I'll just quickly domain and the range. Let's it's all real. Okay, here we go. What is all real, guys? This one, the middle one. You see how 3 is given here? It will be all real. Right? All real. Okay, however, this one, for the domain, we need to let x plus 4, we need to keep this greater than or equal to 0, right? Hence, your x has to be greater than or equal to negative 4. So x is greater than or equal to negative 4 is your domain. And for your range, again, it's flipped, right? It's flipped, and then it was pushed up by 3 units. So it will be starting from 3 and below, okay? So it's y less than or equal to 3. What about this one? Your 5 minus x has to be greater than or equal to 0, and then hence 5, x is less than or equal to 5, isn't it? So your x has to be less than or equal to 5 then. Okay, what about the range? Well, the range is the same as usual. What usual? Like this is the usual square root of x graph, right? So it will still start from 0 and forward. So it will be y greater than or equal to 0. So, okay, so these are the domain and the range of each function. Now, let's look for the inverse function and its domain and the range. Now, for the inverse function part, so domain and the range of the inverse function. And let's look for the expression as well. Well, since, we got the domain and the range already, shall we look for those first? So domain and the range, remember the rules? Swap them around. So here, the domain should be less than or equal to 3, and the range should be greater than or equal to negative 4. And for this, it will be all real values for both, because, it's the same for both. And then the last function has x as greater than or equal to 0 and y as less than or equal to 5. So just simply swap them around. Isn't that simple? And for the expression part, let's follow the rules. What was the rule number 1? Swap the x and y. So you must swap the x and the y, right? And then start moving everything to the other side and find out what your y is. So that will be giving you, I'll do it step by step. Okay, so technically we get x minus 3, which equals to negative root, right? Hence, square root of y plus 4 should equal 3 minus x, right? Cancel out the negative. And then you square it. What do you get? When you square it, you see why we did the entire, rational function, radical expressions before. You actually have to, do the squaring thing on both sides in order to get the inverse of the functions too. So anyways, so you will be getting, can I just keep it as it is? It's not that important here. That will be equal to y plus 4. So technically, y then should equal 3 minus x squared minus 4, right? So that will be your inverse function expression for your first function. And for the second function, so number 1 and number 2, okay, let's move it around. X equals to cube root of 3 minus y. Okay, now, cube root basically means what, guys? To the power of 1/3. So what do we have to do to cancel this out? You have to cube it, right? So cube this and cube that. So we put x cubed on one side, and that becomes 3 minus y. So that y should equal 3 minus x cubed, right? So that's number 2. Okay, so finally, number 3, the third expression was equal to f of x equals to square root of 5 minus x. Swap it around, square root of 5 minus y is what we have. X squared is equal to 5 minus y. Y equals to 5 minus x squared. So technically, the inverses of each of the function is, okay, so first one, inverse is 3 minus x squared minus 4. The second one is, inverse is 3 minus x cubed. And finally, the inverse is 5 minus x squared, right? So that's how we can simply get the domain and the range of the inverse of the radical functions given here. So domain and the range are very important as well, because especially for this, if you graph 5 minus x squared, guys, well, how would you graph it? Honestly, what are you going to graph when you are graphing 5 minus x squared? You will be graphing a parabola flipped downward, starting from 5, right? This is the graph of this, but because for the domain for this should be only positive, we are only actually graphing this part. You see? You see how? So that the domain is the positive values only, and the range goes from 5 to below. The domain is really, really important. Okay? So don't forget this, and then, understand how to apply the domain into the inverse. You don't get the entire parabola, you only get half of it. So this is the end of radical functions today, guys. So thanks for listening.